Today, we'll be solving LeetCode 871, minimum number of refueling stops. We are given a car that starts at position 0 and needs to travel to a target position eastward. The car begins with some amount of fuel, and it consumes 1 unit of fuel for every mile it travels. Along the way, there are gas stations. Each station is described by its position and the amount of fuel it can provide. Whenever the car reaches a gas station, it may stop and refuel by taking all the gas available there. Our task is to determine the minimum number of refueling stops required to reach the destination. If it is impossible, we return -1. Now, this might sound like a dynamic programming problem at first, but the most efficient solution uses a greedy strategy with a max-heap. Let's think about why. Imagine the car driving toward the destination. As it drives, it may pass by multiple stations. We do not need to stop at every station immediately. Instead, whenever we are about to run out of fuel, the best choice is to refuel from the largest fuel station we have already passed. This greedy idea works because choosing the station with the most fuel at the right moment gives us the longest possible reach. To implement this, we use a max-heap. As we travel forward, we add the fuel amounts of stations we pass into the max-heap. If at any point our fuel is not enough to reach the next station or the target, we pop fuel from the max-heap and refuel. Each time we do this, we count it as 1 refueling stop. If the heap is empty when we need fuel, that means it is impossible to reach the destination, so we return -1. Now, let's go line by line through the code to understand how this is built. We start by importing the heap library, which in Python implements a min heap. Since we need a max heap, we simulate it by pushing negative fuel values into the heap. Next, we define the function. Inside, we first initialize an empty list to serve as our heap. We also set a variable named result to 0 to count the number of refueling stops. We set a variable named current position to 0, and a variable named fuel to the starting fuel amount given in the input. We also append the target itself as a station with 0 fuel. This is a trick that helps simplify the loop logic, because now we treat the target as just another station we need to reach. Next, we loop through each station. For each station, we get its position and the fuel amount it provides. Before trying to reach this station, we calculate how far it is from our current position. If our current fuel is less than the distance required, then we need to refuel. While fuel is not enough to reach the station and the heap is not empty, we pop the largest fuel value from the heap, add it to our fuel, and increase the result count by 1. If the heap is empty and we still cannot reach the station, then we return -1 because it is impossible. Once we can reach the station, we subtract the distance from our fuel and update our current position to this station's position. Then, we push the station's fuel amount into the heap as a negative number so it behaves like a max heap. After we finish processing all stations including the target, the result variable holds the minimum number of stops. The time complexity of this solution is O of n log n, because for each station we may push fuel into the heap, and in the worst case we may pop fuel from the heap. The space complexity is O of n, for storing station fuels in the heap. So the main pattern here is a greedy algorithm with a max heap, where we always refuel at the largest station we have already passed when absolutely necessary. And that's how you solve LeetCode 871, minimum number of refueling stops. Thank you for watching and let's keep learning.